Well, good afternoon, everybody. I want to welcome you all to the April edition of the WIRES webinar on technology. And with us today, we have Greg Marecki, who's CEO of Continuum Industries. And with him is Sharon Darcy. She's the chair of the Linear Infrastructure Panel. And they're going to talk to us today about how they use artificial intelligence to help streamline and accelerate the permitting process. I want to invite all of the attendees to submit any questions they have as we go through the presentation. You can do that through the question function, which is on the right-hand side of your screen. Just tap that on, type in the question, and then I'll make sure that Greg and Sharon get the questions after they're through with their presentation. I want to get us going so we can hear what they have to say. And with that, I'm going to turn it over to you, Greg, to tell us more about artificial intelligence and permitting. Thank you.
Fantastic. Thank you so much, Larry, and thank you to the WIRES team, and very good to be here. Thank you for having us. So, as Larry said, I'm one of the founders. I'm also the CEO of Continuum Industries. Continuum Industries, I'll tell you more about the company itself in a minute, but fundamentally we are a technology company, and yes, we are here today to talk about artificial intelligence and the infrastructure development permitting process. And I'm also joined by Sharon, and we'll be sharing the scene. What's ahead of us? I think I'll be preaching to the choir here, but we're all very conscious of the scale of the challenge when it comes to expansion of the grids. And I really like this quote. You'll see a lot of UK references here because that's originally where Continuum Industries comes from. But I really like this quote from the president of National Grid in the UK, where it just illustrates the scale. And she said that in the next 7 years, National Grid in the UK will have to develop over 5 times more projects than they did in the past 30 years. So it just illustrates the scale of the challenge. And I'll get back to why that matters in a second. But we know that all of those projects that have to be developed when it comes to new transmission are notoriously difficult to take through all of the different stages, right? Whether there's environmental impact on forest, because we have to chop down the trees, or we have to cross close to local towns, local communities, and there will be visual impacts associated with that, or the route might have to cross somewhere close to cultural heritage sites, protected areas, where the visual impacts again will be impacted very heavily. It's a very complex process with a lot of moving parts, and the pressure from stakeholders is increasing, right? Because there's more and more infrastructure heading their way very often, and there will be hotspots inevitably, and there's more and more scrutiny and more pressure that's coming from the local communities or different environmental and permitting bodies. And simultaneously, the resources that are available when it comes to the expert resources are limited as well, and the time is limited to do this. So unless we do something differently about how we approach the project planning, project development, and permitting and stakeholder engagement process, it will be really hard. It will be simply really hard to get this done within the time we have available. And at Continuum Industries, well, obviously being a technology company, we believe that technology does have a role to play, and we'll show you a little bit of how that might work, and maybe some case studies and some examples of where this has worked. But Continuum originally started out in the UK. We started out of Edinburgh in Scotland, so a lot of offshore wind, a lot of renewable power, renewable generation coming here, and then, well, Scotland is already running pretty green when it comes to the greenhouse gas emissions. But say down south in England, London, all of the industrial clusters, it's not so rosy, right? So we were born as a company in 2018. And we really kind of started into that process of trying to get the power from the north of Scotland and from the North Sea down south to London, and huge projects in association with that. And the technology we developed, we called it Optioneer, and it's an AI-powered platform to help those projects move faster through the permitting process. So far, we've assessed over 25,000 miles of projects. We've been involved in over 88 projects at this point, over a dozen countries and hundreds of users active every month within our platform. And we handle all types of linear infrastructure, right? That's the especially difficult type. So that will be overhead lines, that will be underground and submarine power cables, that will be pipelines as well, hydrogen, CO2, and water. And we've got what we think is some pretty impressive examples of transmission companies deploying this kind of approach, this kind of technology that we've developed to really bring big impact into their projects. And one example is from Scottish and Southern Electricity Networks, who did what used to take them 12 months in 8 weeks. How? We'll get to that in a second. But as we all know, there's a lot that can be done within the internal process in terms of streamlining, automating for each developer, but it can only take us as far without kind of looking outside and engaging with the local stakeholders and with all of the relevant permitting bodies. And I really like this diagram here on the right. I think the first time I saw that was I think one of the WIRES meetings a couple months ago. I'm pretty sure it was. It's from the National Electrical Manufacturers Associations, and it shows all of the different steps, right, that a project has to go through. Right? Are there any protected habitats? Okay, we've got to get a permit for this. Is there any impact on air quality? Okay, we've got to go and talk to the EPA. Are we going to be crossing any BLM managed lands? Okay, we've got to get an approval. And each time, if we don't get that, it's game over. So as a technology company, we saw that there's an opportunity for technology to really change the dynamic in the permitting process, in the project development process. And where it's not just about streamlining and making things a bit faster, a bit smoother and more efficient, but actually integrating all of that and making it lower risk, but also lower impact. That's really where we started speaking to Sharon, and we helped to start that initiative called the Linear Infrastructure Planning Panel. And at this point, I'd like to hand over to you, Sharon, to take us through what happened with this and really provide the take from the stakeholders' perspective, right?
Thanks very much, Greg, and it's lovely to see and join you all this afternoon in American time. I'm speaking to you from London, and I'm the chair of the Linear Infrastructure Planning Panel, which, as Larry has told me already, is a real mouthful. But what I want to do is to share with you the experience that we've had in the UK with linear planning. So not just transmission lines, distribution lines, also major water, sewage pipelines, transport networks, etc. And how the panel that we've set up in the UK can help overcome some of the permitting challenges that exist in infrastructure of this type. And next slide, please, Greg. So Greg's already sort of taken you through some of the issues around the challenges of delivering large quantities of infrastructure to meet decarbonisation goals, energy security goals, but also issues around sort of nature positive solutions, nature recovery that in the UK we're clearly focused on. And this clearly needs to be done at scale and at pace if we're going to meet those national requirements. Getting so much infrastructure in a small congested country like the UK is causing all sorts of problems around permitting and consenting. We haven't got vast swathes of open land. We live in sort of very crowded towns and cities. And so getting public acceptance for new projects is proving a real challenge. And there are increasing numbers of legal objections that are starting to come through in the system as people say, hang on, why do we need this infrastructure? Why should it be built here where we live, where, as Greg has said, there might be national monuments or at sites of a special biodiversity interest? But there are also other challenges that we all know exist in infrastructure planning, and those exist around coordination and coherence. Just having one transmission line on its own is no good if it doesn't relate to an energy network, and having energy networks that might not be supported, for example, by water resources, communications resources, harbours, ports, etc., is also an issue. So how do we get infrastructure that's built and consented, which is really more coherent and consistent? And how do we ensure that that is sufficiently flexible to cope with the challenges that we know are coming down the track and already here in many respects in terms of climate resilience and climate impacts? New technologies can help in all these areas, but the area that I really want to focus on this evening, UK time, this afternoon in your time, is the one around public permitting and consenting and how technologies can help there, and what the Linear Infrastructure Planning Panel has done to try and improve this and to help this process. So next slide, thanks, Greg. So you might ask, well, what is the panel? It has a very specific purpose, and that's it was set up to engage key public interest stakeholders in the development of good practice in the use of new technologies in this infrastructure planning area. So key public interest stakeholders, you might say, well, who are they and why are they important? The panel deliberately has very diverse membership. It's got membership from across social and environmental, non-governmental organisations who, if you don't get them on side, can be quite vocal opponents of planning issues and can lead to legal challenges. But we've also got a range of data and environmental data experts and planning experts who really understand the spatial planning system. Too often in the past, much of the discussion around planning in the UK has been around technical energy systems planning, balancing the grid, balancing mechanisms, etc. When you want to build infrastructure in a particular place where people live or where there are existing interests, the spatial planning teams and networks come to the fore, and we've included them in our panel. And we've also had observers from government and regulatory bodies, so Ofgem, who are our energy regulator, Scottish Government, our Environment Agency, which looks at environmental data and environmental impacts. So the panel's a very diverse group. It's worked in collaboration with industry. So we've built up networks with big project developers, so transmission operators, water companies, etc., and other stakeholders who have an interest in infrastructure planning. So investors, for example, who might be interested in environmental social governance impacts, ESG impacts. And not only in the UK, but we built these networks, they're starting to be more international. So we've aligned our work with that of the Global Infrastructure Hub, for example. And we've looked across energy and water. So this network that we built, this collaborative engagement mechanism, has really helped us think through how technology can help in this area, how we can maximise the opportunities, as Greg was outlining, and minimise the risk, so that people really trust the new technologies that are out there and start to use them as business as usual, rather than something which is an innovation project right off on the edge. And we've been delighted to work with Continuum. Greg and his team have shown real leadership in this area. They kicked the process off, but we are independent. Everything we do goes in the public domain, and we try and socialise it as widely as possible. So we've socialised it with other AI and tech companies who are developing products which might look at sort of forecasting and budgeting, for example. Next slide, please, Greg. So when it comes to technology and permitting issues, it can really help us move, tech can, from incremental change in planning and permitting, which still might lead to bottlenecks in the system and stop you building the new wires and networks that you need, to transformative change. But for tech to be able to do that, we've identified as a panel 3 key things that really need to be addressed. First of all, it's using tech to support engagement processes and collaboration processes, to support decision making. It's really important to recognise that technology, AI, will not make decisions for you. You still have to have people who might have legal accountabilities and vires, whether they're government actors or project developers, who have to make the decision. But technology can show you the information that you need to make that decision on in new and wonderful ways, which I'll go into in a moment. Secondly, for technology to have this transformative effect in the permitting system, it needs to be accompanied by appropriate data, and this is often overlooked. Lots of AI runs on massive data sets, as we know. So unless you get the right data and feed the right data into the model, you won't get the right responses and the right information out. And thirdly, for technology to have a transformative effect, it needs to be trustworthy and secure. As wires businesses, you're very, very aware and familiar with the sort of critical infrastructure risks and the need for security in this area. And also, you won't want to change your processes and procedures unless it's to something which can be trusted. And the panel has looked at what trustworthy tools and techniques might be in this area. So next slide, please, Greg. We've done deep dives into different areas, and as I said, all our information is in the public domain. Our website is lipp.org.uk, and you can find all our briefing papers and our latest white paper there. The white paper synthesises everything we've done over the last year, and it sets out recommendations for key actors in the UK. Now, you might say this is UK specific, but I think there are some lessons you might be able to learn here from the problems that we've had. In terms of what government can do, we've recommended that our government needs to digitalise our planning system far more quickly than has been the case, and to digitalise our permitting system. A lot of what we do currently in the UK is a paper-based or at best PDF-based, and clearly that's very difficult if you want to move at scale and pace. Our panel I was very surprised, was very supportive of the move towards digitalised permitting. They recognise that post-pandemic, when we've all been on Zoom calls for more hours than we could care for, people are used to using technology in different ways and used to digital systems in ways they perhaps weren't used to in the past. In terms of data, the panel has recommended that government audits the data that might need to be used for permitting decisions and co-creates appropriate data sets where there are gaps. This is really important if you're going to get decisions based on the most important things that the public, as well as the industry, thinks are relevant in a permitting issue. And to do that, we also have recommended that government needs to look at not only cost, geology, time, but also look at social, environmental and economic impacts and data around those impacts when making decisions. And we did a real deep dive into exactly that issue. We made a bunch of recommendations for regulators, so including that regulators should develop trustworthy frameworks that tools such as Greg's Optioneering tool can work within. And that involves looking at the appropriate transparency, accountability and assurance mechanisms that you need as a wires business to trust the technology that you're going to use and to persuade your stakeholders, your community groups, etc., that this is really trustworthy and secure and that they can rely and place reliance on it. But new technologies won't take off on their own. There needs to be a pull. And the panel recommended that regulators have a role here in terms of incentivising the use of trustworthy and secure tools and technologies, and particularly around the creation of new markets. New technologies like Optioneering can radically change and transform the way that permitting works. That can open up whole new exciting opportunities which really can help move from a more adversarial process to a more supportive one. But regulators need to work with that process and with that change and support it. And lastly, we made a bunch of recommendations for project developers, so transmission operators, distribution companies, etc. And that's around supporting the development of platforms which enable earlier, ongoing and more dynamic engagement and collaboration and optioneering. So enabling community groups, statutory consultees, local authorities, local councils to interrogate the different options there and really explore alternatives. And we found that that can really help build trust and confidence in the decision-making process and support for the eventual proposals coming forward. But we, as a panel, recommended that this needs to happen not only at the project level, but also at the strategic level. And you might know that our government is in the process, and our energy systems operator is in the process of developing a strategic spatial energy plan. So technology can help at that level as well. And lastly, for these new techniques to take off, we really need to think more about the procurement processes that sit behind them and sit behind new ways of doing business. So next slide, please, Greg. The panel has already had a significant impact in the UK. We've had an impact in terms of understanding, in terms of strategic spatial planning. So in the past, this hadn't got as much airwaves and as much money, as much budget as technical systems planning. But our National Infrastructure Commission recognised in its National Infrastructure Assessment 2 that was published last year, partly as a result of the panel's work, that this is really important. In terms of the potential for automated tools for transmission planning, partly as a result of the panel's work, this was flagged in the Electricity Network Commissioner's report into accelerating transmission infrastructure that was published recently. And lastly, the panel's recommendations in terms of AI assurance and how you can trust AI are recognised now in our Department for Science, Innovation and Technology's Responsible Technology Adoption Portfolio, which lists all different types of AI assurance. So the panel has already had an impact. We've got ideas of all sorts of things we want to do in the next year. And one of those is developing an international knowledge exchange for smart permitting and consenting. Another is developing tools for permitting which aren't designed specifically for developers, for transmission operators, etc., but for communities. So really trying to flip the debate by giving communities more agency and control. And we're looking at things like metrics that are in difficult areas such as carbon and supply chain. So lots of ideas, and I really hope that you found this helpful and we'll be able to learn from our UK experience. Thank you.
Perfect. Thank you so much, Sharon. So some of you might be wondering, AI for permitting webinar, tech talk, but we're talking about initiatives like that. We're talking about this because AI, it's been a bit of a buzzword, right, for all of us over the last year or so, with ChatGPT, OpenAI, and all of that. But just a lot of uncertainty around what it is, how it works, how it can help. Does it help? Is that a threat? Is that an opportunity? And I think initiatives like this are really here to make sure that technology can be helpful in the context of planning this critical infrastructure. It can be trustworthy and it can be reliable and secure in this context and fit for purpose. So all of this, I think, structure built around the technology is necessary to really make the most out of it. And that's, me saying it as a technologist, as someone from a technology company. But back to the AI, back to the technology itself. So, okay, how do we turn that 12 months of project development into 8 weeks? And sure, 12 months is not the entire permitted developed project. It's very much that initial phase of identifying and working through all of the different corridors and routes. And so our way of thinking about this was, we saw that there are so many different steps and so many different disciplines and so many different stakeholders that all sit in silos and speak to each other and are considered sequentially. So what we did, we started going through the list of all the things that have to be considered. And one of those things on the list, to give you an example, is visual impact, right? So an overhead transmission line will have some visual impact, very often very considerable. But typically, it's only possible to consider it in detail at fairly late stages, right? Because it's a lot of work, it's a lot of uncertainty, right? If those routes are tens of miles long, if not hundreds of miles long, how on earth would one be able to consider that very early on? Well, if you turn that into a mathematical model, such as describing the height of the tower, height of the pole, the terrain, and height of the viewer, you can actually calculate those things very efficiently at scale and very early on. And that's the idea behind what we have been developing at Continuum Industries with Optioneering, in order to help those projects move faster and in a more flexible manner from start to a permit. So very early on, if you don't have the ability to consider visual impact, you will move past that and you might miss some considerations, right? So what we're trying to do is we're trying to capture as much of that insight as early as possible and introduce it to the project development process as early as possible, when the cost of making changes is still fairly low, right? And the risk of hitting roadblocks is lower as well. And we do that for all of the different disciplines. And I think that's the unique element about what we've done here with Optioneer and what technology is now allowing to do at scale. It's integrating all of those different disciplines, be it engineering, technical, environmental, permitting, social aspects, say the angle of crossing of existing highways, existing rivers, the installation methods, depending on the ground conditions. All of those things can be considered super early on in order to inform those projects. And what we've done is we've put all of that into a platform that helps those projects to go from the very beginning, from the very start, all the way up to a permit. And it all starts with geospatial data, right? We've got to bring in all of the geospatial data about what's actually out there, be it existing forests, water bodies, those roads, highways, existing buildings. And we've built a baseline data set, in the case of the USA, that considers over 100 sources and over 1,000 different constraints or features, for that matter, different layers, to speak technically. And all of that is maintained on a regular basis, and more data obviously can be added as those projects progress locally. The second step to making a technology like this work is to then consider, okay, we've got all of the data, what do we do with it, right? How does an urban area influence whether I can cross through it with my transmission line or not? How does a protected area or a national park influence whether I could build an overhead transmission line through it or not? So all of that comes in. Then you might want to consider the installation methods, right? Depending on where I'm going and what the data conditions are, I might want to use different installation methods, right? When crossing underneath a river, I might want to use a horizontal directional drill. Whereas in other cases, if it's say a wider river, I might actually opt for a micro tunnel when doing a cable. And similarly, right, when crossing through woodland forests, I might want to use different installation methods as well in order to mitigate the impacts. Now, doing that at scale is really hard, and that's what technology enables us to do here. Another example of technical parameters that can be standardized within that is the sort of setback distances, be it from existing buildings, existing forests, or protected areas, or environmentally sensitive areas. All of that can be baked in, and there's dozens of different considerations just like that. All of that coming together in order to then produce what we would call almost like a resistance map that describes how those different layers impact the ability or kind of the preference to route a transmission line through a certain location. And then all of that information, the geospatial data, the constraints, the parameters, the penalties, the preferences, the resistances, costs, all of that feeds into an engine, into that AI algorithm, and that AI algorithm will then generate millions of potential ways to route a transmission line from location A to location B. And what you're looking at here is a simulated way of routing transmission lines in that kind of webbed format between different substations. And each of those red areas, each of those heat maps represent millions of potential alignments. And the hotter they get, the higher the probability of finding an alignment, a route that meets the predefined criteria for the project, be it from the cost perspective, be it from the minimized environmental impact or social impact or minimized permitting risk. But now, where does it all come from, right? We've generated some routes, we've generated some corridors. How does it all come together? Well, and some of you might say, algorithms like that have been around for 20, 30 years. And that's true. Least cost path algorithms have been around for about 20 to 30 years now. Some of you might have even used them in ArcGIS as a standard plugin. The problem with the old method is that it only considers the penalty as considered at each kind of location. We know that there's so much more to this, right? Depending on the geometry of the route, depending on where it's going, what kind of technology we're using, a combination of underground overhead, it might be changing. And the least cost path algorithms that have been around for those 20 years haven't really been suitable and haven't been able to capture that nuance, which means that they never caught on. They never quite started getting used. I think there was a study from EPRI that produced a model to use those least cost path algorithms, but they still omit a lot of the construction, installation considerations. And you might think, okay, we're using artificial intelligence, but what is it, right? How do we tame it? How do we control it? Well, the good news is that it doesn't have to be a large language model for it to solve the problem. In this case, it doesn't have to be a machine learning algorithm, which cannot really be explained. It is a different algorithm, which is still classified, at least in our case, well, it is classified as artificial intelligence. In our case, we are using evolutionary algorithms, which combined with least cost path and many other types of algorithms allow us to evaluate those thousands, hundreds of thousands, millions of potential alignments within hours. So what you're looking at here is the algorithm trying to generate routes between point A and point B on a map, right? So at the top, you can see a map, and the algorithm is drawing alignments automatically. What you can see at the bottom is a graph. It's a chart which shows on the x-axis the calculated environmental impact, and on the y-axis it shows the cost of construction, right? It shows the capex. And each of the alignments, each of the routes that gets plotted on the map is then evaluated against dozens of those design rules, against all of those considerations, and plotted and evaluated on this chart. And as you can see, we can interrogate them, right? If we wanted to, we can see what they are. But the algorithm automatically works through millions of those and then presents that heat map that we saw before. And as you can see, it's trying to, as it's iterating, it's moving left on that chart. That means it's finding routes that have lower and lower environmental impact. And then eventually it produces what's called a Pareto front, which basically shows the trade-off between capex and impact. So just to kind of simplify, it takes the geospatial data, the rules, the mathematical models, the unit costs, the penalties, the impacts, then it generates hundreds of thousands, millions of potential routes, and then it proposes the heat maps, the corridors, as well as individual alignments, which then can be iterated on. And, you know, an algorithm can only go as far, right? But what it does is it enables a much more nimble, much more agile process. So we've seen projects which have had as many as 80 to 90 users within our platform, both internally within the developer team as well as externally, from consultants, specialist consultants and contractors who'd collaborate together and take those initial routes, those initial alignments, and iterate on them together within the same space, right? So they would move the line, they would change the shape of the corridor, and they would still recalculate it, run it through the algorithm to assess it. And in the same space where they have that data analytics, they also have 3D visualization. So I was looking for a place where there's a lot of data and a lot of fidelity. Why not put Manhattan on it, right? So the same place that has the data analytics that are specific to transmission routing and all of the parameters can also have the high fidelity 3D data for collaboration and visualization. And then that data needs to be plotted in a way that can be explained, right? So in this case, we again have 2 points on the map that we're trying to connect. We've got a number of potential alignments, potential routes. Along those routes, you can see those different icons. Those different icons represent what's happening along the route, right? Are we crossing existing rivers, existing roads? Are we crossing any protected areas? Where do we have angle towers, which then impact cost? And then on the right-hand side at the top right, you can see this Pareto front, right? So you can see again, x-axis being, well, actually in this case it's flipped. So x-axis is our technical risk and y-axis is environmental impact. And we can see again how those different alignment options perform in terms of different criteria that might be predefined. And then all of that can be turned into an alternatives assessment in a simple red, amber, green table, where we are effectively reporting against each of the criteria, against each of the considerations that we might have to report, say, to the local utilities commission on. We can present this in this fairly familiar format for each of the routes, for each of the alternatives. And then, okay, we presented how those things compare at a top level, but then we've got to present a baseline assessment of what's actually happening there. And that data can be exported out of the technology as well, right? So we might plot how many crossings there are, how many buildings there are within 300, 500 feet of the central line. We might plot, say, the costs, the capex, the opex, or as here, we might then start digging deeper, right? Give me the exact list of all schools within my corridor or within, say, 500 feet of the corridor. And in order to do that, the user doesn't need to have GIS training, right? They don't have to be a GIS professional to run some sort of advanced GIS processes in order to analyze this in ArcGIS, right? It's all presented in a format that's accessible to, say, a project manager, right? Because the project manager needs to get the job done quickly. Now, you might be asking, you might be thinking, oh, how does that actually impact permitting, right? We're talking about AI for permitting and technology for permitting. Well, it's very often the project manager, right? Or someone who doesn't have the GIS training or technical training that needs to interact with all of the different stakeholders. And those different stakeholders will be asking questions, right? Give me the list of the schools that will be impacted, the hospitals, the addresses of the parcels that would be crossed. And typically that would take days, if not weeks, in order to get that feedback from someone else in the team. Now it's all built in a process that's accessible to those people, and they can have those conversations much faster. You can then produce tower schedules and calculate costs of how it all matches up. Sure, it's going to be initial tower schedules, but all of that can be produced really quickly. And then at the end of the day, out of the same place where you were generating your routes, you can then produce a video with a flyover to show at a consultation event or show it to stakeholders. So it's all about kickstarting those projects from zero to that first iteration in days and moving them fast at pace at minimized risk. So we opened last year an office in New York as a company. We started out in the UK. So while we do have some fantastic stories in the US, I can't share them for confidentiality reasons just yet. So I'll show you very quickly, and I'm very mindful of time, a few examples from the UK. But in the context of the US, you can not only run the routing studies, but you can take it as early as corridor or interregional and regional assessments for network planning, and then run it all the way up through competitive bids for competitive transmission projects, all the way up to kind of environmental and permitting studies. So an example from the UK, I'm sure that's, I think, very similar to that kind of long-range transmission plan that MISO recently produced, was in another region where the transmission company had a few different layouts for the network, and they had a preference for one of the layouts, but actually they ran it through our system and they found within only 2 months of work, they found that there was another layout that was permittable and deliverable within 3 years faster than they originally thought, just because they were able to run that sort of preliminary routing very early on. And that had huge impact in terms of reducing congestion costs, if obviously those projects are delivered within that time. Another example, right, I spoke earlier to that 12 months in 8 weeks. SSEM transmission in the north of Scotland, large 400 kV projects, did 12 months in 8 weeks, and were able to engage the communities faster than normally would have been possible. 10 months earlier engagement, which then kept the project on track while iterating with the local stakeholders. Another example, in this case competitive, this was, so Muirmore is an offshore wind farm in Scotland, and in this case Muirmore needed to connect themselves into the grid and develop a transmission project and transmission cable, a submarine and an underground cable. And in just 8 weeks, they were able to analyze over I think it was 5 potential substation locations, 17 landfalls, and make a case to the system operator for where they should be connected, showing something that was already de-risked much more than competitors looking for that same connection. So throughout that life cycle, there's room for technology to be leveraged in order to move those projects forward. So for us as Continuum Industries, and I think in general, for the technology developers, there's an opportunity to help those projects move from start to permit much faster at much, much less risk. And that's really what I wanted to leave you with today. Thank you.
Well, thank you, Greg. Thank you, Sharon. Really interesting how that technology works. I want to just remind folks, if you have any questions, to go ahead and type them into the question function on the right, and I'll be glad to work them in. I'm going to go ahead and start in the meantime, get us thinking a little bit here. And this is actually a fairly kind of fundamental or basic question, perhaps, but who are the typical users for this type of technology? Is it the transmission owners, transmission companies, or is it going to be more at the consultant or the contracting level?
Yeah, so it's a very broad range. So we've seen more and more transmission companies and developers say, okay, now over the last 30, 40 years, we've been in the mode of more asset owners, asset operators, and we've been focused on maintaining, but they are looking to develop more and more kind of project development and permitting capability. And in those cases, we're seeing more and more transmission companies leverage this directly and work together with us. And then what we do is we actually don't limit the number of users on each project. So the most successful projects we've seen would have as many as 80 users on them, both from within the project developer as well as external. But we've got equally, some companies might not be looking to do that. They might still be looking to keep working with their consulting partners, consultancy partners and contractors. And in those cases, we've got partnerships with companies like Power Engineers, who then come in as subject matter experts and operate the technology on behalf of the developer. So it's both, really.
Well, great. And then the other question I have is really kind of focused on the data, because that seems to me like it's a critical component here in order to make sure you get good results coming out of it. So where do you get your data from? How do you make sure that you've got the adequate quality and completeness of the data in order to run these?
Yeah, that's, I mean, without data, rubbish in, rubbish out, right? If that's not right, then just very little that technology can do. So ourselves, for the US at least, we've built a data set of over 1,000 layers and different considerations that need to be or should be taken into account when planning those projects. And that serves almost as a baseline data set, which is fairly complete, but it's not quite everything, right? Because we can't go and speak to every single local authority in relation to every single project. So what the technology facilitates is to really quickly start with a fairly mature baseline data set to understand as many of those constraints and considerations and avoid roadblocks very early on. But then as the project progresses, that data set is going to evolve as there is more and more feedback from the local authorities, from surveys, from local specialists, from the local communities as well. Where do they go to walk the dog, right? And don't want to see their transmission lines? Where do they play golf? All of that stuff can be brought in over time. And what's great about tech is you can just recalculate it really, really quickly and update the analysis. So that's the flexibility, I think, that's introduced into the process that normally wouldn't be present.
And can I just add that was a big thing with the community groups that we were engaging in our panel. They like this dynamic, more responsive process rather than sort of set piece events where they put in an input and they have to wait a very long time before they hear any answers.
Yeah, I was just going to ask, it would seem to me that the really time-consuming part of this would be right up front with trying to make sure you've assembled and gathered all the data and then constructed the algorithm, at least initially. How long does that take?
I mean, well, we've been working on this for the last 6 years to get this working right. So on the algorithm itself works, it runs, it's been proven to do that. The data set for the US, we have been developing for the last 18 months or so in order to actually have that up and running for the GIS layers. But you're right, for each project, effectively, each company, each developer, each subject matter expert will have their own value system, or each region will have their own value system, and that needs to be captured. Usually that can take as little as 2 to 4 weeks if the team is actually on top of it, right? If there are no additional delays. That obviously gets refined over time and iterated on, but the initial process takes just a few weeks. And then you can reuse it and productize it, right? So every single project that comes after that can reuse the same set of assumptions. So you're effectively productizing it and making it much more repeatable. And
then as you're moving forward with the project, you're continuing to refine and make adjustments to that data as it goes forward. And I assume it's probably not anywhere near as much time as it is up front, right?
Yeah, absolutely. And I think there's another opportunity there, which was flagged during the panel by one of the regulators. They flagged, why would we not have a pre-agreed data set with us, right? Why would we as a regulator not rubber stamp a number of data sets that need to be considered and keep that up to date in one place for everyone to use in the same way? So I think it's not even just for each developer to develop their own, to build their own version of it, but potentially also for the regulators and all of the data providers and stakeholders to have something that they say, this is what you have to consider when developing this type of project using this type of technology.
Sharon, I wanted to ask you about something because I think you were the one who touched on it, but it has to do with the security considerations around the technology and the data that are gathered for it. Can you talk a little bit about what some of those considerations are?
Well, clearly, when you've got critical national infrastructure, you need to really think very carefully about not only cyber security issues, but sort of associated physical security issues. And this came across really strongly in terms of the members of the panel and the regulatory and government bodies on the need to ensure that the technology was going to be sufficiently robust. So what we did was we looked at sort of different assurance mechanisms that exist around AI tools, etc. And we didn't find anything that was really specific and bespoke enough in this area at the current time. So using a collaborative process like the panels process to say, well, what are the key areas that are important here? How might they be taken on board? How might they be standardized? Is the way to sort of start to feel through what AI regulation might be in this space around security. But Greg, I don't know, you've been sort of looking at your own assurance mechanisms. Where are you on that?
Yeah, I mean, absolutely, right? So, for example, for us being originally a company that started out of the UK entering the US region, we had to, for example, or we immediately stood up US servers that would be managed by Amazon Web Services on American soil within US jurisdiction, so that the data doesn't have to leave the country even, right? It remains in the same region and is controlled. So very much data residence, security certifications, be it ISO, SOC 2, all of those things need to be taken into account and tackled up front. And the data, if someone puts in their own private data for, say, cost functions for their own projects, like, that's not something they would want to go out to the public, especially when doing competitive transmission. So all of those things need to be front and center.
Starting to get a couple of questions coming in, so I'll turn to those. First one I got is, they're asking, what level of cost estimating for the routing analysis, plus or minus percentage, does the AI reach?
So this is very much the preliminary assessment. So we're probably talking about, give or take, 30. I want to putting a finger in the air, about 30% planning design maturity. It's not going to be complete, but it's going to be way more complete than just applying a cost per linear mile, right? So it's going to bring in the ground condition considerations, the crossing considerations, land acquisition, and very often it comes down to how much data the developer team or just subject matter experts are actually willing to put in. So I think it can be pushed really far, but it comes back to what you, Larry, said about the upfront investment. How much maturity and fidelity do we want to add into the model? So it can be as simple as a mile of a conductor of this type costs this much, or you can go as deep as a cubic feet of excavation of this type of rock costs this much, based on this volume of foundations. So you can build fairly intricate models with it.
Sharon, I wanted to ask you about, you talked a little bit about considerations on trying to incentivize the use of this technology. And I think that most of your comments were focused on incentivizing stakeholders to use the process, either through the development of platforms or things like that. Was there any consideration to incentives for the transmission owners or the consultants or those folks to use this technology?
Well, I think there is an issue. There can be an issue around sort of inertia in the system and companies being risk averse for very good reason. So there's a need to say, actually, the benefits here can be significant. We're not going to be able to meet our goals, particularly in the UK, around net zero, unless we get faster methods. But how do we get the confidence in risk-averse companies to do something differently? And that's why we've been saying, well, the transmission companies, they can see by example and they can share experiences. But we think that the regulatory and policy frameworks that shape a lot of the work that the transmission companies do need to actively incentivize these new tools and techniques. So unless there is a pull, we don't think that they will be used as quickly as we need them to be used in order to deliver our national goals, particularly around decarbonisation.
And Greg, it looks like you've had some success using this tool in Europe for different projects. As you're looking to the United States, are there any particular obstacles here in the US that you don't face in Europe? And how would you think about trying to address those types of obstacles to using this technology?
That's an interesting question. So we've done a lot of validation and testing, and I mean, the first thing that you immediately see when you look at a map in Europe say the roads are very wavy, right, and entangled. When you look at the map in the US, it's gridded, right, 90 degrees perpendicular parallel. So for us, that meant making sure that the algorithm is appropriately adjusted to that. So there was a big investment up front in order to make this work on a technical level. There are obstacles, I would say, similar, because the stakeholders, right? We have built rapport, and we've received a lot of feedback from stakeholders, say including through the panel. Now we are in the process of doing that in the United States as well. So that is a process, that is a journey. Some things are different, right? Each region, even within the US, right? Some regions will care more about visual impact, other regions will care more about cost, other regions will care more about wildfire risk, right? So all of those considerations need to be brought into account. I mean, definitely I can tell you that in Scotland, wildfire risk is not high up on the agenda.
Got it. All right. Well, we're getting pretty close to the top of the hour, and I'm not seeing any other questions coming in. So Greg and Sharon, let me thank you for joining us today. Very interesting tool that I think can be part of the toolkit for helping to get needed transmission built. So thank you for being here. I really appreciate it. And I want to thank everybody else for joining us here today. We will continue our series. We're going to probably skip the month of May, but we'll pick it back up again in June. So keep an eye out for emails and notifications regarding the next in our series. So thank you everybody for joining us. Thank you, Greg. Thank you, Sharon.
Thank you so much.
All right.
Bye-bye.
Bye now.
Bye.